Hi, and welcome to another old steam-powered machine shop. That intro was a little family history on my father's side and some of his very early mechanical adventures, which all happened way before my time. So you can kind of see where my interest in steam came from. This will be about the last shot from down here. We're going to pack up and head to New York, and next few weeks I'll have another video out starting up the New York shop under steam power again. A lot of things I got to do, get things operational. I got to make a trip down to the coal mine, pick up some coal, and the planer project is moving along fairly well. I have a couple riggers that are interested in the job in the Wilmington, Delaware area, and I've got a hauler and someone at the New York end to unload and move it in. So things are looking pretty good there. Thanks again for all the support and the help you guys are giving me on that. And I think we'll have a good time with that machine and learn a few things. In this video, I wanted to finish up a little bit more on the Pickering Governor rebuild project. And if you look, maybe I'll put up a photo right in here of the Lang engine that was my dad's. The Governor is actually mounted horizontally, which was common with a few manufacturers, and probably the Pickering is one of the few Governors that will run on its side like that. In fact, that Lang engine was one of his favorite engines, and if you're ever at the New York Steam Engine Association show in Canandaigua, New York, that club owns a Lang that for a while we thought could have been his old engine, but there's too many things different about it. For one, it doesn't have a clutch in the flywheel, and you can see on the photo of my dad's engine there was a clutch and a few other things, but it's the only known example of a Lang & Button steam traction engine. And I remember him telling a lot of stories about the Stevens engine. That was a much bigger, heavier engine, and it was probably the biggest engine that was around Bradford County at that time. And when they were hauling that sawmill around the country, setting it up on different sites, they would haul it with a couple of wagons behind the Stevens, and he told about bringing along a lot of extra timbers. For one thing, they sawed a lot of mine props. There was a good market for that, mine props and railroad ties. And they brought a lot of props and ties with them so they could get under a bridge when they came to it and kind of assess the situation. Of course, the back roads out in the country back then, the bridges were not maintained hardly at all, except maybe by the local people that lived around there. And they'd assess the situation and get under the bridge and shore it up with timbers and plank and whatever they had, and run the engine and the mill across it, and then pull their timbers out and carry on. So that was an interesting time to be involved in machinery. So we'll get right to the video, and next time we see you, we'll be in the steam powered shop. Thanks a lot. This is spring steel I get from McMaster Car. They have it in a lot of different thicknesses, and this is 20 thousandths. The original springs in Pickering Governors, all the ones that I've seen, have been like 18 thousandths when you measure them up here. And I used 18 thousandths on the last Pickering that I overhauled a couple years ago in my old videos, you can see. And that's the Governor that went on the Morris engine, and I think it was a little too light because the Governor was overly sensitive, and so I'm using two 20s and one 18 together to make the stack up in this one. Actually doesn't drill too bad if you got a really good drill and keep it sharp. Okay, this will be my pattern. Okay, I got all the pilot holes drilled in these. I've found that drilling a small hole first really minimizes the tendency of the final hole drill to wobble around and be out of dimension. I don't have a carbide drill or a really good drill to drill these 1/4-inch holes on the ends, but I did have a masonry drill. Now these things are kind of amazing what you can do with them if you gotta grind them. And it was oversized widthwise this way a little bit, so I took it over here on the grinder. And when you grind these it becomes a spade drill. So you want to be sure you got enough back rake on it, and keep the angles the same. Not really critical what it is, as long as they're the same this way. And then I adjusted the diameter of the drill by grinding the sides. And when I did that, instead of grinding it over here where I was having interference here with the grinder, I ground it this way, and I kept it below center so that I was putting a little side rake this way on the outside edge of it. And I mean, it's not tremendous, but you'd be amazed what you can do with these drills, especially if you got to get a broken bolt or something out. I mean, it's only going to be as good as you grind it. But the carbide is not bad, and they're cheap. Okay, so here's the carbide drill. I slowed the drill down to its slowest speed. I could probably stack these all up and drill them at the same time, but I don't want to take a chance of having them catch it. Works just as well without any lube, because the drill's going so doggone slow that it's not building up any heat at all. There's hardly any burr on the other side. I'm happy with that. This will probably mess up my paint job a little bit, but can always touch it up. Well, as it turns out, the broken screw here is a 1232, which, as far as I can see, does not exist anymore. It's a totally forgotten, obsolete size, probably taken over by quarter 28, which is very close. So this is a quarter 28 screw I get from McMaster-Carr, and I cut one down to the height that this is, and drilled this just slightly to make it tap drill size for quarter 28. I forget what the size was, and it's going to be quarter 28. This is cast iron and it taps very nice. Oh, you can buy 1232 taps. You can buy 1232 dies if you want to make a screw from scratch. That's fine. But I cannot find any screws. Okay, there's one thing you got to watch out for with taps. If you go to a catalog and look at taps, you'll find a lot of times an H number. It'll be like an H2, 3, or 4, something like that. That has to do with the amount of clearance there is in the thread. Like supposedly an H3's got 3/10 clearance in the thread, and this particular one, I just grabbed a bunch of taps when I came south here, and I wasn't really looking at them. But this is an H2, and that screw would not screw in there. I got another tap which didn't happen to have any H designation on it, and the screw goes in quite nice. Now, most hardware store taps are like a lot of clearance, like H4s. So if you want a nice, really tight fitting hole, threaded hole for your screw to fit in, just make sure you're using an at least a minimum H3 tap. So I got to mark this one because this one is quarter 28 and the rest are 1232s. These are sticking down too far. Now I gotta trim all these. That's not good. Miscalculation. Well, we'll do that. Come back. Okay, I got these all trimmed to the proper length and tightened down. Should do it. Now these parts here have to be poured full of lead. They aren't very tight right now. That'll tighten them up when that lead gets poured in there. Lead sinkers. I'm going to just trim off the excess lead with a sharp putty knife. Get underneath it. You can just get the corner a little bit. See that one? On this end, I cut a piece of cardboard so that it would just fit around these gear teeth tight as possible to seal the leak from the lead, and made a little block here to hold everything straight. And that should set down on there tight enough just to pour that lead in there. There you can see it was a pretty good fill. And that tightened the brass bands up really tight.